Hello everyone, welcome back to the channel and to a new video. Today it's monthly installation day, so we are going to install Arch with the April 2022 ISO. We're going to install it with the encrypted BTRFS file system, which was very requested. We're going to install it with Timeshift, AutoSnap, and the KDE desktop environment, and also ZRAM. So without further ado, it's going to be quite a long video. Let's get going. So here we go, guys. This is the monthly installation of Arch with the April 2022 ISO. You can see we have some new colors here on the login prompt. Now I will install this on a virtual machine, and you can see here I logged through SSH to that machine. I had to give the root user a password on the virtual machine, and once I've done that, you can connect using the SSH command root at and the IP address of your virtual machine that you can find out with IP space A. And once you enter your password, you can basically install your Arch installation via SSH. So now I'm logged in here as a root user. You can see I am on the Arch ISO. Now the first thing here I'm going to do is to actually check again my internet connection by typing in IP space A, which is now coded actually with color, which is easier to read. You can see my machine has an IP ending with 156 here. This is the same IP I used to log in via SSH, of course. So let's clean up the terminal with Ctrl L and type in lsblk. You can see also in this machine I have one disk called SDA, which is 50 gigabytes in size. So what I'm going to do in this video, I'm going to install Arch here. This is going to be a little bit more complex because we're going to install Arch with the BTRFS file system and with encryption. And we're going to use a special encryption method here. So we're going to create a EFI partition because this is a UEFI machine, and also one partition which is going to include a root and a home subvolume. We are going to encrypt this BTRFS file system here, and later we are going to install a ZRAM and also Timeshift and Timeshift AutoSnap. So let's get going here. Let's begin the installation. The first thing we want to do is to partition our disk. So to do this, I'm going to use gdisk because it's a tool for partitioning disks with the GPT label. So I'm going to type in here gdisk and then /dev for device and then /sda. So creating new GPT entries in memory, that's fine. So the first partition we are going to create is the EFI partition. So N for new, the partition number is 1, that's fine. And for the first sector, I'm going to accept the default by hitting enter on the keyboard. And the last sector defines the size of the partition. In this case, I'm going to do plus 300 megabyte partition for the EFI partition. That should be enough. Now the code for this partition is EF00. That's the code for the EFI system partition, as you can see there. And next we're going to create the next partition, which is going to be our BTRFS partition. So N for new, and I'm going to accept here all the defaults for the partition number, the first sector, and the last sector. The code as well. And now we can write the changes to the disk by typing in W and confirm by hitting Y and hit enter. And you can see now if I type in lsblk, we have there SDA1 and SDA2. So now we created the partitions and we need to now format them. Now let's begin with the EFI partition. That's an easy one. So let's type in mkfs.fat-f32 because we want it to be a FAT32 file system type, being an EFI partition. And then the partition path again is /dev/sda1 and then hit enter. Now, before we proceed partitioning our BTRFS volume, we need to first create the encryption. Now, before we are going to encrypt the partition, let me open up here a new terminal just very quickly. And let me increase the font size here so that you can see better. I'm going to put it here on the side and I'm going to increase it here. So this terminal is actually on my main machine. This is not on the virtual machine. You can see the login prompt is different. And let me type in here crypt setup, which is the utility we need to encrypt the partitions, and then --help, because I want to show you the defaults for this utility. So you can see here, let me actually decrease a little bit the fonts here so that you can see maybe a little bit easier. So you can see here we have the defaults for the cipher. So the cipher is basically what's defining the encryption of your partition. And you can see because we are going to use LUKS encryption on the partition, the defaults for LUKS encryption are AES XTS plain 64, which is fine. We have the key and the hashing, which is 256. So this is actually not what I want in this video. I want to actually create a SHA-512 encryption, which is also slightly faster on a PC with a 64-bit processor. And then it's using the dev u random by default. So I want to use this option, and I want to use also this option, but I don't want to use the 256. I want to use the 512. So we're going to create this from scratch, basically. So let me close the terminal. And let's now encrypt the partition by typing encrypt setup. Then we are going to define the cipher. So -- cipher. And we're going to give in the defaults that we want for this cipher, which are already defined. So I need to type in here aes.xts.plain 64 and then -- hash. Now for the hash here, I'm going to create the SHA-512, which is the key I want. And then I'm going to use also the -- use -random that we had already as a default before, and also -- verify -passphrase. And then we're going to specify the LUKS format, and then our partition path, which is /dev/sta2. Remember, this is the one we created for the main partition. And that's gonna be it for it. So we can hit enter here. So are you sure you want to do this? And I am. So I need to type in here yes in capital letters and hit enter. And now I need to enter my passphrase for the partition. So I'm gonna enter one passphrase here, and we'll have to verify. And it's going to take a moment here to encrypt the partition. And the encryption is now done. So now before we can format this partition, we need to open it. Now to open it, we can use the crypt setup lux open. And then the partition path again is /dev/sta2. And then the name we want to give to the mapper partition, which is going to be created, and we'll need to mount this later when we are mounting the partition. So I'm going to call this partition root very simply. And thanks to ZSH here, which is correcting my typo, and yes, it is script setup, so I'm going to hit Y here. So we need to enter the passphrase, and it's going to take a moment here to decrypt the partition, and now the partition is basically open, and we can now format it. So let's format the partition by typing in mkfs.btrfs, and then we need to use the mapper device, which we just created when we opened the partition. So /dev/mapper/root, and then hit enter. So the partition is now formatted. Let's clean up the terminal with Ctrl L, and again lsblk. You can see there, again, we have our two partitions and the encrypted root partition, which is now open because we just formatted, but it's going to be, again, encrypted when we reboot our machine. So now that the partition is formatted, we need to mount it and create our subvolumes. So let's first mount the BTRFS partition by typing in mount /dev/mapper. We're going to use, again, the mapper device here, /root, and we're going to mount this on /mnt. And then hit enter. Now we can move into the mnt directory to create our subvolume. So cd/mnt, and let's create now our subvolumes. So the first subvolume I'm going to create is the root subvolume. So BTRFS subvolume create, and I'm going to define the root subvolume with the @ and then hit enter. Now I want to create also a home subvolume, so I'm going to pull up the last command here with the up arrow and add home at the end of the @ to create the home subvolume. And so these are the two subvolumes I want to have in my system. So I'm going to go back to the main directory here with cd and unmount the mount partition. So umount /mnt. And I unmounted the mount partition because now I need to remount the two subvolumes I just created in there with its own options. So I'm going to type in first mount -O for options. Now the options I'm going to use for BTRFS are the usual options I'm using all the time. One is no access time, so no A time, to make the access time of the disk a little bit faster. I'm going to use also the space cache, and I'm going to use version 2 because that's the one that works. The space cache version 1 is not working. And I'm going to use also the compress option. I'm going to use here the ZSTD compression method. I'm going to use also the SSD option and also the discard equal async option, which is basically going to optimize the performance of the SSD. And those are the all options I want. I need to also use, of course, the subvol to define the subvolume equal to the root subvolume, because we are mounting here the root subvolume first. And then we need to define the mapper device. So /dev /mapper/root, because this is the device we want to mount, and we want to mount it under /mnt, and then hit enter. Now, before mounting the home subvolume and the boot partition, we need to create the directories for those. So let's type in here mkdir and /mnt, because we need to create those partitions in there. And I'm going to open the curly braces here and create them both at once. So I want to have the boot partition and also the home partition. So the boot directory is going to be used to mount the SDA1 partition, which is the EFI partition, and the home directory is going to be used to mount the home subvolume. Then I can close the curly brace and hit enter. So I'm going to pull up the last two commands here because I want to use the same options for the home subvolume, but I need to change the subvolume and the directory to mount it on. So the subvolume is not the root subvolume here, but it's the home subvolume. And the mount point is not the mount directory, but mount/home, and then hit enter. So now I can mount basically also the EFI partition by typing in mount /dev/sda1. I don't need any option here, on /mnt/boot, and then hit enter. So for this tutorial later, I'm going to use systemd boot to boot up the machine, and we are going to need to configure also the encryption in there. So basically the mount points are now done, and we can proceed by installing the base system. So let's type in here pacstrap /mnt, because we want to install the packages in the mnt directory, which is our installation directory. And the packages I want to use are base, the base packages, and then Linux for the latest Linux kernel. I'm going to install also the Linux-firmware package to install the basic firmware for the computer. I'm going to install also Git and Vim, my editor. You can of course choose Nano or any other editor if you prefer. And I'm going to use also AMD-U code because the machine has an AMD processor. And that's going to be it for the base installation here, for the base packages, better said. And then I can just hit enter. It's going to synchronize the repositories and install the packages. You can see also there, this ISO is installing with the 5.17.1 kernel, which is the latest Linux kernel available. And it's going to take a moment here to install the packages. So I'm going to pause the video here, guys, and I'll be back with you once it's done. So the base packages have been installed. We need to now generate the file system table for our mount points. So to do this, we can type in gen fstab -U to use the UUIDs of the partitions. And we're going to take the ones we have on /mnt, and we're going to append them to /mnt/etc/fstab, which was just created now because we installed the base packages. So this is now done. We can move into the new installation here by typing in arch-chroot on /mnt. Again, remember mnt is our installed directory. So you can see the login prompt change because we are now in the new installation here. And the first thing I'm going to do, I'm going to work on the mkinitcpio.com file because we are using encryption and I want to define also the BTRFS module. So to do this, we can type in vim/etc/mkinitcpio.conf. And then the first thing is under modules here, I'm going to insert BTRFS. And if I scroll down here to the hook section, which is down somewhere here, we need to enter here before file systems the encrypt hook. So let's type in here encrypt and a space, of course. And we can save this file and exit the editor, whichever editor you're using. I'm using Vim, so it's :X. And now because we inserted the hook there, we need to recreate the init RAM fs. And to do this, we need to type in mkinit cpio-p on Linux. And that's because we installed the Linux kernel and then hit enter. So next, I'm going to download my script to install the base packages for Arch. So I'm going to use Git for this, git clone, and then https:// and then gitlab.com/eflinux, that's my username, /arch install base. Now this is my, again, private repository. You can use the public repository, to which I will leave a link in the video description below. So replace the name of the repository. Instead of arch install base, I think it's arch install public. And you can replace basically the name of the repository there, and you will not be asked to authenticate, unlike in this case, because it's my private one. So let me enter my username and the password. And now if I type in ls-l, you can see I have arch install base there on the top. So we need to move in there. So cd arch install base. And again, ls-l here, and I have my kind of scripts. Actually, these are just command lines. They are not really scripts here, nothing really fancy to see. The one I need right now is the base script. So let me type in vim base.sh. And I have here basically the commands used to install Arch. Now, I've done many tutorials on installing Arch line by line, so you can check those up if you want to have more infos, and I'm going to do others, of course, in the future as well. But for this, I'm going to use this basically script, which is including the lines to install Arch. So I'm going to use here this command to create basically my local zone, my time zone, synchronizing the hardware clock and the system clock. I'm setting the locale here by basically deleting the hashtag on line 178 of the locale.gen file, which is the English US locale, and then generate the locale themselves with locale-gen, entering the same string here on the locale.com file, entering the key map for my keyboard, which is not a US keyboard, on the vconsole.com file, creating the hostname on the hostname file here, and also creating the hosts entry with these three commands here, and also creating the password for the root user. So let me actually show you this because some of you had issues with this password command here. So basically what happens here, we are basically creating the password name password for the root user. The ch password here is actually the command used to create this password. The password we are creating here is this one. And this is actually the command used to do that. So if you want to change the password for a used user, you're going to change this one here and not this one here. So replace this password with the password of your choice. And the same goes also for the user down here. So I'm creating here a user named after me because it's my user. And if you want to change the password for this user, change this password here and not this one. This is the command used to change the password. So just remember that because some of you, I think, had issues understanding this. Then I'm going to install here some packages. These are the basic packages I use to install Arch. So what I'm going to change here, I'm going to actually need to confirm. I want to confirm here, and I don't want to install grep this time because I'm going to use system dboot. So I'm going to eliminate this. And yes, I'm going to use network manager here. I'm going to use the other packages. I can actually delete a reflector because it's there twice. I always forget to delete this in the repository. I think I'm going to leave everything else as it is here. And so down here, if you have an AMD card, you can basically uncomment this line, which is providing you the driver for AMD cards. And if you have an NVIDIA card, you can uncomment the second line, which is providing you everything for NVIDIA. Now I'm going to comment out here this line for grep because we are not going to use grep here. And these are basically system CTL controls to enable services in the system. Now down here, I'm basically creating again the user, giving it a password, making it member of the libvirt group. This is useful if you're using virtual machine manager, like in my case. And with the last line here, basically I'm giving the command to give sudo privileges to the user. And at the end here, I'm just printing in the terminal, type exit umount-a and reboot. Actually, umount-a is wrong because that's not the command. I need to change that as well. But that's all there is to it here. So I can just save this file. And I need to give now execute permission to the script, so chmod plus x on base.sh. Gonna go back here to the root file system and run it from there. So /arch install base and base.sh. So generating the locales, asking me now to confirm the packages, and I'm going to accept the packages here, the default packages. Now for the XDG desktop portal here, I'm going to choose the third one because I'm going to choose KDE afterwards as a desktop environment in this case. So number 3 is fine. I want to remove IP tables because it's in conflict with NFT and proceed with the installation. So this is going to basically install the base packages I usually use. Of course, feel free to change them as needed. And so this is going to take a moment to install. So I'm going to pause the video here, guys, and I'll be back with you once it's done. So the packages are now installed, and there is still something we need to do here, which is a very important step, and that's to create our bootloader with the encryption options. So this is a little bit complex because we are using systemd boots and we are using also encryption. We need to put in the options in there. So just follow me and I'll try to make it as simple as possible. So let me clean up the terminal. So to install systemd boot here, we have nothing to install. Basically, packages are already there because it's systemd. But to install the bootloader, we need to type in here bootctl. Then I'm going to define the path, which is --path equal to /boot. You remember this is the directory we created for the bootloader, and then just install very simply, and then hit enter. So you can see there it created some entries, and we need to basically edit some of these and create one. So the first thing I want to do is to edit the loader.com file. So to do this, I'm going to use Vim again because it's my editor, but change this with your editor. So Vim /boot/loader/loader.conf. This was created now because we installed systemd boot and then hit enter. So I'm going to change here some of these options. So for the timeout here, I'm going to remove the hashtag and I'm going to say here timeout 5. So basically it's going to time out for 5 seconds. Well, actually, because of this video, I'm going to do 10 seconds. So I have a little bit more time before the machine boots up. And I'm going to type in here also default arch. And that's all there is to it. And then I can save this file and exit Vim. Now, default arch means that the arch entry is going to be the default entry in the bootloader. Now, the arch entry is not existing yet. We need to create that one. So we're going to do this in the next step. So let's create now the arch entry by typing in Vim /boot/loader/entries. And if I hit tab key here, there is nothing in here. So we need to create basically the arch.conf entry. So let's create now our entry. So I for insert mode in Vim. The first thing is the title. And the title is going to be, in my case, Arch Linux. Next line is the Linux. We need to define basically which kernel we want to boot. So, and that's the standard one, which is VM Linux with the Z-Linux. In the next line, we are going to also define the init_rd. So init_rd, and that's our init RAM FS. So that's going to be init RAM FS -linux.img and hit enter. Now, this is actually where we need to define the encryption options. So let's begin by typing in options and then crypt device equal UUID and then equal. Now we need to put in here the UUID of the SDA2 partition, followed then by the UUID in the next option of the mapper partition. So where do we find these UUIDs? Well, we find them actually in the terminal, but let's say for now this file with :x in my case, and let me clean up the terminal. So the UUIDs of the partitions, you can actually find them out with the blockid command, for example. So blockid, and let's say /dev/sda2. So you can see the UUID in this case, it's this one right here. And if I type in here blockid on /dev/mapper/root, which is our encrypted device, you can see it has another UUID, which is this one right here. So we need to put these two informations in the arch.conf configuration file for our bootloader. How do we do this? Well, that's fairly simple. We can pull up again the last two commands here. So for the STA2, and we are going to basically append this information to /boot /loader/entries/arch.conf and hit enter. And we are going to do the same thing here for the mapper root. So we are going to basically append this information to /boot /loader/entries/arch.conf. So now let's go back to the configuration file. We pull up here a couple of commands. So this is the one, vim at bootloader/entries/arch.conf. And you can see we have our options in there. Now we need to clean up here some stuff because we have too much. We don't need everything. So the first one we need here is our SDA2 partition, not the encrypted one, but the partition itself. So I'm going to basically delete this UUID here until the UUID number. And I'm going to put it here after UUID equal. And I'm going to delete also the double quotes here and remove basically everything else because I don't need anything else from the first partition here. But what I need after the UUID is to define the :root. You need to tell this is the root partition you need to boot. And then we can define the root is equal to UUID. So the UUID of the encrypted device. So equal, and we're going to take the UUID of the encrypted device, which is the mapper root right here. So I'm going to basically remove all the information because the only thing I need is the UUID itself. So let's put it here and let's go at the end of the UUID here, remove the double quotes, and I'm going to remove everything else because I don't actually need any other information from the block ID command here. But what do I need to define the root flag? And that's equal to subvol equal the @ symbol or the root subvolume. So basically the root flag is on the subvolume, which is equal to the root subvolume, and then read and write. So these are the options I need for systemd boot to work with encryption with BTRFS. So this is almost done. Let me save this file and exit Vim. We can also optionally create a configuration for fallback. And to do this, it's very simple. We can just type in here cp for copy on /boot /loader/entries/arch.conf. And we're going to basically copy the name of this configuration and rename it. So /boot /loader/entries/arch. Well, it's actually not arch.conf, but it's going to be arch-fallback.conf, and then hit enter. And we can basically change one option in this fallback configuration. So let's edit it. Vim /boot /loader/entries/arch-fallback.conf. And the only option we need to change here is the initramfs. Instead of initramfs-linux, it's going to be initramfs-linux-fallback.img. And the rest is going to basically stay the same. So we can now save this file and exit Vim. And I think this is all there is to it. So we can now type in exit and go back to the root arch ISO, unmount our partitions by typing in umount -r/mnt. It's going to take a moment to do this. And now I'm going to type in exit and pull up here the virtual machine because I want to see the reboot with you guys. So just hang on a second here. I'm going to type in here exit. And it's closing the connection via SSH. And I'm going to close the terminal and pull up the virtual machine. So let's see if everything worked out. So let's type in here reboot. It's going to take a moment to do this. So you can see here we have Arch Linux fallback and Arch Linux arch.conf, and it was selected by default because we specified this to be the default option. So we're going to boot up now the machine, but I'm going to define here at the end of the line actually the video resolution just for the virtual machine. So that's going to be equal to 2560x1440, and then I can hit enter. So it should pick up my display resolution. You can see now it's asking us for the passphrase for our encryption. So let's enter that. And now we should be able to boot up our machine just fine. So you can see we have a login prompt. So I'm going to type in my username here and the password. And now we are in our new installation. So let's check first if we have an IP. So IP space A. So you can see there I have an IP ending with 157, and that's because I'm connected via Ethernet. Now, if you have a Wi-Fi connection, you can type in NMTUI to use the Network Manager Terminal user interface. Go to activate a connection. You will see a list of networks here. You can select yours. You will be asked for the passphrase, and then you will have an IP as well. Then once we are done that, we can type in here sudo pacman-sy to synchronize our repositories. Need to, of course, authenticate. And you can see we can synchronize just fine. So let's clean up the terminal and continue our installation. So the first thing I'm going to do is to install Paru, the helper for the AUR. So to do this, I'm going to type in git clone https://aur.archlinux.org /paru-bin. So I'm going to install the binary because it's a little bit quicker to install. So it's going to clone the repository. Now we need to move into the directory which was just created. You can see that I have paru-bin, so cd paru-bin. And to make the package, we just type in make pkg-si. So it's going to take a moment here to make the binary. And then we can basically install packages from the AUR using Paru. And this is now done. So we can exit the directory here. And so the packages I want to install from the AUR are Timeshift, because we are using the BTRFS file system, and also Timeshift AutoSnap. So let's do this by typing in paru-s. So timeshift-bin. I'm going to install the binary because, again, it's a little quicker. And also timeshift-autosnap. And I'm going to install also ZRAMD to create my ZRAM devices using ZSTD compression. And then I can just hit enter. So it's going to take a moment here to make the review. And for the packages build is fine. Proceed with the installation of the dependencies. So it's going to take a moment here to install all the packages plus the dependencies and make the binary. So I'm going to pause the video here, guys, and I'll be back with you once this is done. So the packages are now installed, and the next thing I need to do is to enable the ZRAMD. Now ZRAMD comes with the systemd service, so it's fairly simple. We just enable it by typing in sudo systemctl enable --now zramd.service. And you can see now the symlink is created, and if I type in lsblk, we have there our ZRAM device with 8 gigabytes, more or less 8 gigabytes of swap. Now, if you want to change the options for the ZRAMD, you need to change the options in the configuration file, which is under the etc directory. So you would type in sudo vim/etc/default/ZRAMD. So here you can see, for example, the maximum size is going to be 8192 megabytes. This is only megabytes. You can change also the algorithm here. You can change the priorities and also skip VM eventually. So if you want to change these options, this is where you can change them. So I don't need to do this. I can just save this file and exit Vim. And next, we are going to install our desktop environment. Now, remember, we have the Arch installed base repository, my private repository. If you install the public repository, it's going to be Arch installed base. So we need to copy this in our home directory here. To do this, we're going to type in cp-r to make it recursive, so to copy everything in there, /arch installed base. Replace this again with the repositories you downloaded. And the dot defines this current directory. So we're going to copy it in our home directory here. So now again, ls-l, you can see Arch install base is there. So let's type in cd to go in there. And again, ls-l. I'm going to use this time the KDE script since we want to install KDE. So vim kd.sh. So here what I'm going to do, actually, I'm going to comment out also the reflector command because I do already have the optimized mirror list. So I don't need to resynchronize here the repository as well. For the firewall ports here, I'm going to do this eventually later. I don't need to do this right now. It takes a little bit longer. But what I want to do, I want to, of course, install my packages here for KDE. So we are installing Xorg, SDDM, the display manager, KDE applications, and some other applications, and also some fonts that I need for my installation. So Spotify, I don't need to install that yet, and enable SDDM. This is all there is to it here. So we can save this file and exit Vim. And I need to give execute privileges to the script, so chmod plus X on KDE.sh. I'm gonna go back here to the home directory and run it from there. So /arch install base and then KDE.sh. And this time I'm gonna set all the defaults again. And again, here the defaults. And I'm going to accept again the defaults. Now this is going to take some time to install, so I'm going to pause the video here, and afterwards we're going to reboot the machine, configure Timeshift, and then it's going to be done for the installation. So I'll be back with you guys in a moment. So all the packages have now been installed, and you can see also the display manager was enabled. So we're going to reboot the machine. So reboot. So again, Arch Linux is the default configuration. So I'm just going to hit enter here. And we need again to authenticate for our encrypted partition. And if everything went well, we should be greeted by SDDM. So there you go. This is SDDM. So let me type in my password here. And welcome to the KDE desktop. So you can see we have now here our KDE desktop up and running. I'm going to go to settings here and go down to about this system. You can see we are using Arch Linux here. Plasma version is 4.24.4, and we're using an AMD processor. So the last thing here we are going to do is to configure Timeshift. So let me pull this up. We need to, of course, authenticate. And we can set now this up. Now it detects that we have BTRFS, so that's fine. We can click next. So this is the encrypted volume we have, so that's fine. It's the one we have. Now you can set here the schedule. For me, this is fine. You can change it, of course, according to your needs. So queue groups is already enabled. That's fine. I'm going to leave this on. And this is basically all there is to it. So we can click finish. And you can see here AutoSnap already created a snapshot when we installed the desktop environment. And that's because it was installed before we installed the desktop environment. So because we basically upgraded our system or we updated our system, it created a snapshot. But I can take one also right now. And you can see it takes it literally in like 1 second. So what we did in this video, we installed Arch Linux with the April 2022 ISO with encrypted BTRFS, ZRAM, systemd boot, KDE, Timeshift, and Timeshift AutoSnap. I hope you enjoyed the video, guys. If you have any question, let me know in the comments below, and I'll try to answer you as soon as I can. So there we go. This was the monthly installation of Arch with the April 2022 ISO. We covered a lot of stuff in here. We covered encrypted BTRFS, ZRAM, KDE, Timeshift, AutoSnap, systemd boot, and much more. If you have any question about the video, let me know in the comments below. I will try to answer you as soon as I can. And I thank you so much for watching the video, guys. If you haven't subscribed yet, please do so. That helps me a lot. So I wish you a great day, guys, and I'll see you very soon in the next video.